So if people are joining this live stream, this is continuation of a complex design discussion about RDF, SPARQL, and generally graph-based ontological and other representations in Wolfram language. So, should I run this code here? Or is that hopeless?
That's hopeless, I guess.
Okay, always good to know.
So
okay.
Various things are going to work, but others not, the latest.
Okay.
No.
All right. What should I see here?
So first, a little overview of what we're going to discuss at all. So there are basically 3 or 4 categories of things to discuss. The first thing is just an identifier, which is an IRI, Internationalized Resource Identifier. The second thing is RDF, the Resource Description Framework. And the third is SPARQL, which is a query and update language for RDF.
Okay.
And there are 2 things to consider. First, there's an in-memory representation of RDF data. And you get this RDF data by, for instance, importing an RDF file or by writing it manually. And then writing a SPARQL query against it. So you can see there's a symbolic SPARQL query. The second option is you have a SPARQL endpoint and you send it either a SPARQL string or a symbolic representation of a SPARQL query and get a result.
Okay, so let's talk about our use case of this, right? What's the plan here? Is the plan here to use this as a way to query our surf or what?
The plan is to query SPARQL endpoints and potentially back entities by SPARQL endpoints.
So surf might be one, but probably realistically an earlier outside SPARQL endpoints and custom entity stores.
Okay, but I'm not a big believer in the outside SPARQL endpoints. I mean, all 3 of them that exist in the world after all these years. I mean, but so you're saying for our custom entity stores, that will be a place where we could use this technology to do querying. Is that right?
Yes.
But now our entity stores right now are stored how?
In-memory association or nested association.
Okay, so this is a way of having a custom entity store that is not being stored as a relational database, stored in some other way. Is that right?
Yes. So there are these 2 types of backends that we are considering in the moment. One is relational databases and the other is graph databases.
And this is the graph database case.
Yes.
And for any given entity store, by looking at the structure, we could potentially decide whether it should reasonably be stored offline as a graph database or as a relational database. Is that correct?
Yes.
Okay. Okay. So now, in terms of the querying, we talked about how this relates to, graph patterns and things like this, right?
Yes. So
is that part of this discussion here?
Yes, after the RDF discussion, there's a discussion of SPARQL in detail with all the possible patterns that you can write.
My gosh.
So first are the query forms that decide what kind of thing is coming back from the query at all. For instance, a SPARQL select returns a list of associations. SPARQL construct returns a graph. And here are the patterns that are supported by SPARQL.
Okay, but how does this relate to our pattern language?
So various of these of SPARQL patterns have a correspondence in the Wolfram language. For instance, the union pattern reuses alternatives.
Okay, but I mean, this is a very complicated setup. What's the first place where we're going to get sort of clear payoff from this? What's a minimal example where it obviously does something useful? That's a very long pause.
Yeah, okay. So one that I personally imagine would be if we take the archive theorems and one day put them in together with mathematical structures in a large entity store, and then say, find me the minimum way how I go from the four-color theorem to the Kepler conjecture. That would be a genuine, non-trivial big use of it.
Yeah, but I mean, okay, that's clearly not an everyday.
No.
No. Okay, so this project seems to have gotten a lot more complicated since I last saw it.
We discussed that Tony would implement the classical SPARQL functions to have a representation of them in the language.
Mm-hmm.
That's what he did.
Okay, so of outside, SPARQL-based endpoints, what are the ones that you care the most about?
I've used Wikidata so far.
Okay. And is it interesting what you can get from that?
I see a lot of contributors. The last time I checked, I saw something like 40,000 active contributors. With active is defined by so and so many contributions in the last months.
And it has a fair amount of data.
Okay, so fine. I mean, we've already got a lot of this data ourselves in other ways, et cetera, et cetera, et cetera. So it's not completely clear.
Yes.
But so again, is there a Wolfram Alpha query that would be? I mean, is this something like, get, all capital cities that are in, on rivers in countries that have whatever. I mean, is that?
Yes, the goal is that you can write such queries against existing entities.
Okay. And what would that query look like? I mean, so right now we have just the entity of blah, and then we have this sort of second argument, which is, population arrow between blah, 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 and blah, 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 something like that.
So it would reuse exactly the syntax that we are going to discuss, the SPARQL query syntax applied to an entity type or a list of entity types. And these entity types implicitly represent an RDF graph. And then in the worst case, this graph has to be materialized before evaluating the query, but in most useful cases, there will be a shortcut to doing that.
Okay, so another question. In terms of the flow of this project, what fraction of it have you done? I mean, are you at the early stages, middle, close to the end? What's the story?
So SPARQL Query and SPARQL Update both pass all W3C tests. That means they are mostly standards compliant, except for things that are not covered by the tests, maybe.
Okay. So you're telling me that apart from the design, which we are not yet sure about, that implementationally what you have is working?
Yes.
Nice. Good. Okay. So now we have to look at the design. All right.
Yes, so, and about the implementation, it's not optimized in every case, and there are still bugs in some converters, but yeah.
Okay.
I mean, it's not to be expected to be in every case perfect, because it does arbitrarily complicated graph matchings, which are known to be non-trivial.
I'm sorry. What did you just say, Michael? Sorry.
It is not to be expected that every case is optimal, because you can formulate arbitrarily complicated graph matchings, which we know can be arbitrarily complicated. So.
Right. Okay. So let's take a look. I thought that was one of those. I read this first of all. Maybe I've been reading too many obituaries here. Okay. Okay. So what is that creature? That's turtle? That thing?
Turtle is one of the formats to serialize an RDF graph.
So if I take that RDF graph and I want to simply display it as a regular, one of our standard graphs displayed as a network, is there a way to do that?
Not directly.
Okay.
So there are some ways to transform or represent an RDF graph as a graph, but this is not directly possible.
Seems like it would be a nice thing to have. I mean, for a complicated one, it's not going to be terribly useful.
I agree. For small ones, it will be useful. Yeah.
Right.
Maybe with maybe a little bit going out of the normal graph things and do a little bit more coloring so that they're easier to understand by type.
Right. But so if we say graph of this or something like that, maybe it gives that. Not sure.
So is that just for typesetting, or should it preserve the meaning?
I think it's mostly for display.
I agree.
I would actually say you apply it to the string graph.
Okay, fine.
Because, yeah, I think that's better.
Yeah, that's fine. Okay. Okay. So there's a graph. Yep.
So now that we have seen the introduction, we could maybe go to RDF a little bit down and start from the small parts building up to the bigger ones.
Well, let me look at this example here. Sorry.
Yes.
Okay. So, oh my gosh. Where did you define color?
So it's a variable, and currently we use symbols for variables.
But how's it scoped?
There's no scoping mechanism. So another option that we would have is having something like a SPARQL variable.
I don't understand what these are doing. What you're doing is you're coming out with, these are pattern variables effectively. And is that right? And you're coming out with the form, with every possible form for these, for fruit, color, and shape. Is that correct?
Yes.
So actually what this more is, it's more like a table or something. No, a different way to put it. Funky. How do you make, if you have an association, okay, and you're going to make the analog of a table for an association. Okay, so if I say association, do we have an association table? No, we don't. How do you do that? How do you make, if you want to have something
where the two columns are the keys and values, or I'm not sure what you mean by table.
Yes, that's the kind of thing I mean.
I would do list add normal association. Add.
Wait a minute. No. But what I'm asking, this construct here, okay, where you are generating essentially this outer product, right? If I'm not mistaken, what you're doing is this thing here is asking. So I could have completed everything here. I could have a specific fruit, etc., etc., etc. No. I'm very confused semantically about what's going on.
So technically, this is a join between the triple patterns that you see there.
Lovely. But what I want to know is, what you're saying is, what comes out here is the data extracted from this database, where for every entity in the database for which you're giving me the fruit, the color, the shape. Is that right? For every entity in the database.
Yes. Or another way to look at it, you're finding all the subgraphs, and then you're returning all the variable bindings that make this graph pattern a subgraph of the whole graph.
Okay, but now I'm completely confused here because there's this IRI here.
Yes, these are short forms because this is normally a longer IRI, and it's using these prefixes to shorten them. It is one of the mechanisms to shorten.
Okay, so this triple here is basically
that's the color of this fluid is color.
no, I understand that. So, but that's an edge in the graph, basically. That thing that goes
Yes.
from a fruit node through a I am that color node to a certain color, right?
Yes.
So what this is doing is it's saying in the graph, find all instances. This is like a cases. It's more a cases than a select, isn't it?
Yes. There could be a different function graph cases that we had mentioned before.
Yes.
Where you use patterns.
Right. But the as far as it's concerned, the knowledge that, see, this is returning something. This is returning a pattern binding. We don't have a good mechanism for that. If I say, if I've got some cases, for example, and what you're doing here is you're asking for the specific binding. So let's say I say f of x blank, comma y blank, and then that matches a particular thing. You're asking for x arrow whatever, y arrow whatever. We don't have any mechanism for that right now.
Yes, we discussed something like a function called matches that returns these matches or bindings.
Yes, which will be analogous to what you have here.
Yes.
Okay. And the reason that, I mean, the thing I'm a little confused by, okay, is that in a cases type setting, what we'll be doing here is we'll be saying, I mean, if it was a graph cases, for example, let's imagine that we had graph cases, okay, and that now these named edges, we discussed that before also. We discussed having the possibility of having on a graph edge, having some representation of a naming on that edge. Am I right?
Yes.
And with some nice notation. Okay. So assume we had that, and assume that, let's imagine that I call this graph edge, which is not a good name, but then what would happen is we'd say graph edge of foo x blank. So then what this would be is it would say graph cases of my graph, comma, graph edge, blah, 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 or in general, this would be a subgraph here. I mean, this in fact could just be a graph that happens to have a single edge. And I'm going to, just for the sake of argument, actually, it's not a completely stupid notation. Is that a stupid notation? Inside a graph to do something like that?
What would be the full form?
I don't know. Named rule or something, or labeled.
It looks nice.
And it would format as X and then a long arrow with a foo on top of it.
That would look beautiful, yeah.
Oh, the problem is that, no, wait a minute.
Stephen,
there's a problem with this.
One problem is that you will internally have double rule because you'll have rule of rule and it's not clear what is the semantic meaning.
Yes, I agree. Okay, so we need some other way of entering this. What's another way of entering this? So I think we had discussed previously some kind of thing where, what can we do here? We could do.
I think we can just write it out.
Okay, fine. All right. So then let's say that this is, okay, so the written out form of this would be graph edge. Do we have Charles or anybody from the graph theory?
No, I didn't think it would get so much into the graph corner.
Okay, but in any case, this would be what we would have, something like that. And what would come out of that, naturally, in a cases type way, would be a collection of graph edges, right? With the x's instantiated.
Actually, it would be a collection of graphs.
Yeah, but clearly here, if we wanted x and y instantiated,
yes.
we could always do this.
Yes.
No. Yes, but I think you, Stephen and Tony, you meant something else. The question was: is the sub part of a graph, or is the sub part of a graph an edge? This is.
Well, I'd be prepared to be flexible on that. I think we'd have to be flexible on that.
I think in a general case, the graph pattern has multiple edges. So the result would be a list of edges wrapped in graph.
Fine. So it's a graph, but then alternatively, just like standard cases, if the right-hand side is given some other thing to do with that binding, otherwise it will be a subgraph that happens to have instantiations of X and Y. Right?
Yes.
Otherwise it would be mapped like this.
Yeah.
I mean, personally, I'm quite keen on seeing a piece of functionality like this. And I don't know what in terms of that property mechanism in graphs, there's another way, there might be another way to represent this. Okay, so I think I get more or less what's happening here. And I don't really agree with, from what I'm understanding, this is very SPARQL pandery, so to speak.
Yes, so the idea is, and we also discussed it with Charles, that we have a SPARQL focused functionality in some context, currently graph store, that is much easier to implement than a very general graph cases functionality. And that would already be valuable on its own.
Okay. Okay. Maybe we should see if Charles can join us here.
I can find him email.
I'll call him.
Okay.
Okay, but you're suggesting that there's something which sort of panders to the whole SPARQL world that might or might not be exposed in the full system context and so on.
Yes.
Yeah, I think so too. At least for the beginning.
Fine. But I think it will be useful to try to implement stuff like this, even if it's only simple cases of it for right now. I mean, this is essentially just a binding for SPARQL here. And I don't fully understand.
The work is, of course, done in returning the result.
Yes, but I also I find the mechanism here really weird with these unbound variables and so on. Really weird. I mean, I would find it more sensible if there was an outer wrapper associated with that SPARQL query that enumerated, because I don't even know what order to put these in. Why is it coming out in this order as opposed to color, shape, fruit?
So in this case, it returns all the bindings for variables that appear in the pattern. And later you can project variables. That means return a subset of them.
Okay, fine, but I'm asking you, even just the ordering, why is it not shape, color, fruit?
Charles will be here shortly.
So the order is not defined. That means it can be any.
Well, I know, but maybe it should be defined. I mean, it's an association, so it doesn't really matter much. But what I'm suggesting is that you wrap this thing in something which essentially declares those variables.
So that you can really could have another argument.
Yeah, that's what I'm suggesting, is that if indeed SPARQL query generally has these unbound pieces, what you should do is to say, what is the name that you're going to use? You should be able to call those unbound pieces X, Y, and Z. Okay, or if this one agrees with that one, X and so on. Or even X blank, possibly. But then you need to be able to have some mapping, which I'm now really confused by, because I think it makes... What is this analogous to? So in other words, what's that?
Charles is here.
Okay. Hi, Charles.
Oh, hi.
Okay. So what is this? We're talking about graph pattern matching. Do you understand what I'm asking? So these variables here, which are going to be sort of presented as keys in this association or nested or list of associations. I'm trying to understand what's an analogous case where you are See, I claim that there are two different concepts. One is the name of the key associated with that position. And the other is simply the presence of a dummy object in that position.
I mean, you want to return something. So having a non-pattern object there is nice. Otherwise, if it's a pattern, you don't know what to return.
No, I agree. But well, look, yes. But I claim what you need is sort of a template for what you're returning somewhere. Look, what you basically need is something, I mean, something like, okay, let me suggest something crazy. Okay. This may be crazy. Hold on. Actually, it's not totally crazy. Yes. Okay. So here's an idea. Okay. And I don't know what the default is, but let's imagine that I don't know how many of these there are, but okay, so let's say it's our fruit graph. And then there's this thing, but instead of this, well, actually, let me write this out in a more explicit way. So y blank, blah, 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 and that's of f graph. I'm so confused. I mean, what I was thinking was something like this. And that's more like SPARQL cases than it is like SPARQL select.
But I think you want SPARQL select of f graph, comma.
Okay, fine. That's not what you had before, but that's okay. But then this isn't quite right. No, I see. Then this goes inside. Right?
Right, then we must only deal with the optional one. If there is a shape, include it, otherwise skip it. Where we don't have a very good, I mean, optional might,
well, nothing.
Medium of optional.
Well, really what it is, it's a nothing like play. If the shape is nothing, then that association doesn't have a shape in it.
Right.
But yeah, I mean, but right now association doesn't prune nothings. Perhaps it should. Okay, so that case prunes, but what you're telling me is this case does not prune, although it absolutely could prune. Can we
I'm not convinced
whether it should prune?
Yeah.
Okay.
Because you might want to use this as a table for fast lookup, and then you really want this nothing.
Well, why would you want there to be nothing there? I mean,
because like I use a long association as a fast lookup table for something.
Yeah, I understand that, but okay, well, that's a separate discussion.
Because then C would disappear, and then I cannot match against C anymore.
Shouldn't this be missing instead?
In which case? In the case where you want it to evaporate?
Yeah, when it's kind of doesn't exist in a query. Well, wasn't found.
Yeah,
but it wasn't missing because you said it's optional. I feel like that's not representing the spirit.
No, but I mean, if I say here D, I'll get missing, right? The issue is whether there's something that causes an association to condense, and okay, but let's put that on the ILD agenda. If somebody can take that to that. Yeah. Do we have a project manager here?
No, I can talk about it.
Okay. So I would suggest something like this. This may not be exactly right, but I think that cleans up the semantics of these otherwise completely crazy, hanging, unscoped creatures here that are just flying around.
And you probably want rule delayed instead of rule, right?
Quite possibly. I'm not sure. I wasn't thinking about that.
So there are some features of SPARQL that are not compatible with these pattern objects, and that might become clear later when we review some of the pattern objects.
Okay, but this isn't going to work. Having these unscoped hanging variables isn't going to work. So maybe they get scoped in some way.
So the other idea that I had, and I had actually implemented it at the very beginning, was having a SPARQL variable with the argument, the name of that variable. It's a little bit related to quantity variable, but it took a long time typing such patterns.
Yes. Well, and also it ends up with something where it's coming out. I mean, the role of the variables as a thing to emit is really weird. That is, I don't know of another example where a variable appearing within something causes it to enumerate on the outside that variable. Do you get what I'm saying? I mean,
actually, we have in relational databases an analog of that, because we have new properties that we are introducing, and we also have variables that define the database columns for the top level. And so what we do, we introduce this entity function with those scoping variables, which we then compile to the underlying database primitives.
Okay, so entity function, explain to me the relationship of entity function to this?
It's just an analogous construct which does kind of the same scoping thing that you are looking for here.
But wait a minute, does entity function produce these kinds of, multi-keyed results or not?
No.
I mean, that's the problem here, that there are, entity function, remind me how entity function works?
So basically, it's a property-like construct that allows you to, it usually has one variable, and then you use that variable to compute things like, for instance, if it's an X, then you can write something like X of price times X of, I don't know, copies sold or something like that. Times X of copies sold. And this is the second argument, and the first will be just X, just like in a function. So, and then it's a scoping construct that basically tells you that you introduce a new property with the value given this product. And
I understand.
Okay.
Yeah, I understand. So that's some kind of dual thing to this. Go ahead.
Yes, we could introduce another argument that declares the variables before we use them.
Yeah, but so what? You're still having exposed variables coming out here. That's the problem.
Yes.
That's not going to work as such.
But they're going in.
But
that's like a polynomial.
What do you mean by that?
Like your input has already the fluid variable, so it's natural that it comes out.
Yeah, I understand, but what?
I don't see why this is a problem.
But they are not coming out directly. What are coming out are the string names, and the variables are presumably can be any dummy thing you can change at will.
Well, it's not string names here. These are not string names. These are the actual variables here.
Oh, are they?
I would think so.
Yeah.
This is pretty loopy. I mean, let's keep going for a second. We're going to run out of time here, but let's just keep going for a minute. So what were you going to point me to? You were going to point me to the RDF stuff?
So yes, here first the RAI, that should be pretty obvious. It's a generalization of URL and UI. And then the RDF. Here's some example vocabulary that the examples will use later. And then we just start by the basics of RDF, which is an RDF triple, with which you can make a statement, subject, predicate, object, then you combine
wait a minute, with things like EX. Oh, I see.
This is the vocabulary I introduced, yeah, for instead of writing the long IRIs, which are supposed to be globally unique identifiers.
Yes.
You introduce some shortcuts.
Yeah, okay, fine.
Yeah. And you collect
Okay, so for example, for us, with respect to our surf, those could be entity objects, is that right?
Yes, so there's an analogy. Everything that is RDF type is more or less considered an entity.
Okay.
So, but this analogy is not complete because in RDF, also properties are entities because they are of type property, which is not the case in our sense.
But
so
we could lift our ones. We could make our properties in some sense like entities and ask
yes,
questions.
That would be nice, by the way, I think.
But this is just a convention and it's not standardized how to interpret these things.
Okay.
So the next generalization from an RDF graph is an RDF dataset, which contains a default graph and some named graphs. And then you later can write queries that by default go against the default graph, but you can address these named graphs and do queries over both or whatever.
Why is it set up this way? Why not just have whatever those leaf graphs are, have some structure that represents that? Why are you packaging multiple leaf graphs together?
So that is just one way to model, let's say, a data set that contains current data and historical data. So by default, if you ask population of Spain, you get the current data and you can ask for the historical data of Spain by querying the other graphs. Later, when we get to SPARQL, I show some examples of that.
Yeah. I think that's a nice construction because, like, if we provide in a data repository entity stores or graph stores with pre-packaged with a nice amount of information, but the user has a little bit more that the user can easily add a little bit more.
I'm a little confused because this doesn't look very computable here. You've got these specific things.
No, that will become clear later when I show the examples. But let's first discuss just RDF and later the querying of these things, because this is the most general, which people currently don't use so much, these RDF data sets. But this is the most general form. Okay. The next are the RDF literals, which are basically a string and a data type that defines what the string means. And here is an example. Yeah.
Okay.
The next thing are RDF blank nodes.
Wait a minute. Oh. I don't understand how this represents this. This is some kind of DTD or something for that?
Yeah, so there's a standard that defines what the data type identified by this IRI means. And in this standard, you can read how to interpret the string in the beginning. And yes, your SPARQL endpoint or whatever can process that further or not. Yeah.
Okay.
Then blank nodes. So in some cases, you don't need to identify a node. You just need to say it's there and it's related to other things. Like if you say the age of the universe is such and such, you have a composite value in general of the value and the unit. And you can use that by using blank nodes, for instance, just an example.
Okay.
The next thing is a language tagged string.
I mean, this is a lot of stuff that is, for which we have other constructs.
So for the language tag, I included only the things for which we don't have an analog, or at least I'm not aware of any.
Yeah, we don't have this. We don't have that tagged string.
So we are, for instance, reusing date object. You can write a date object in a SPARQL query and that will work. Because, there I'm using the analogous operation. So then there are some operations on RDF graphs, like finding isomorphisms or isomorphic graphs, but maybe we can skip that in a first reading. Merging RDF graphs by standardizing apart blank nodes.
Yeah.
RDF collection, RDF entity store. We should discuss that only later once we discuss database backends. And then there are some converters. We can maybe skip that too. It's just some formats in which RDF is stored. And now we start with the SPARQL query.
Oh boy.
So in general, there's a wrapper SPARQL query that encapsulates a query, SPARQL execute that deals with communicating with the SPARQL endpoint. Different query forms like SPARQL select that returns a list of associations.
Which is the thing I didn't like. Okay, but whatever.
Yeah. It's basically doing as close to the standard as possible. Yeah, whatever analogous thing there is in the Wolfram language. SPARQL ask checks whether a pattern exists in a graph. SPARQL construct returns a new graph based on a pattern and a template for making this new graph.
Okay, so this is just really SPARQL translated, a SPARQL binding for our language. Because none of this stuff, like calling it ask to have what's essentially a queue function, is kind of off.
So in a Wolfram language world, that would probably be graph member queue. Yeah.
Okay.
And SPARQL select would be graph cases. Yeah.
Yes.
That's why all of this was proposed to go into graph store backtick context.
Right. But I still want to know how we're actually going to use this. I mean, so, can you give me a ranking? So Wikidata is one SPARQL endpoint that it's out there in the world. I mean, there was an enthusiasm for these things like a decade ago, and then they kind of just evaporated. To my knowledge, there were some medical ones, but I haven't heard anything about them in years.
Well, I haven't used any others so far.
Well, perhaps we better find out what else there is. But I mean, the argument for this, what are some examples in our own use of entity stores? So you gave one example, Michael, involving pure math stuff.
I think it really only pays off if the entity store has a certain complexity. That it makes sense it must have many, or not many, at least a few different types that you can go from one to another, and then find something non-trivial. Otherwise, you're basically back to a rectangular entity property.
I understand. Which is, but I mean, in our semantic relations framework, we do have a certain amount of graphism there.
Yes.
And right now, the implementation that we have of the surf. So is it the case that we could imagine re-implementing the surf using these kinds of constructs? Would that be sensible? Would that be nuts? Would that make it more efficient? Would that make it less efficient? What do you think?
I don't know surf well enough to answer that.
I feel also not equipped to answer this.
I think we should determine the answer. Because this could either be, I mean, it could go either way. It could be more efficient, less efficient. I don't know. I mean, but that would be a case where, I mean, if we were to start from our existing entity structures, what would it look like? I mean, if we were to try to define a syntax for, I mean, right now, if I say, something like entity, I mean, this I consider to be somewhat impoverished syntax. Okay. Something like that, right? The fact that I have to do entity list is kind of funky here. Boy, this list seems to change every time I look at it. And it's crazy that there's a city in that list that I've never heard of. Okay, in any case. Okay, so my question is, in this world, okay, if I wanted to say cities whose population is greater than 1/10 of the population of the country that they're in, okay? So let's write that out. Cities whose population is greater than 1/10 times population of the country they're in. So, Leonid, in terms of entity function, this is an entity function kind of play, is it not?
Yeah, so you start with, at least in terms of the relational, like I could tell you how you would do this in the relational world. So you would start with the entity cities, and then you say entity, you will do something like entity select, No. Sorry. You start with entity select, where first argument is entity class city, so entity city.
Entity city?
Yeah, or entity class city, comma all. Then you write entity function, which is going to be a predicate. Then you say something like small capital city, just a variable, you could call it anything. And then you say city open bracket string population, right? Close bracket larger than 1/10 of, and then you do something like entity property path.
Why is an entity property path of the country?
Because in the relational world, you need to actually go to the table country, which is related to the table city. So
well, okay, but in our world, without the superstructure of relationalism, it would be what country is that city in?
Yeah.
Okay. And then it would be
population.
of that thing, it would be population.
Yeah, I guess this will also work for us too, as a shortcut. Yeah, and that's about it.
Okay. That doesn't seem bad to me. By the way, where am I storing all this stuff? Does somebody know?
No.
Okay. It's probably an ILD SW notes. Tony, do you remember where this is?
Could be graph store if that
Actually,
exists.
there's a thing called SPARQL. I'll store this as SW notes 3 under SPARQL there. Okay, so that's that. Now, tell me the SPARQL analog of that.
I just sent it in the chat.
Oh, very efficient. Thank you. Okay, so let's take a look at this. Okay, hold on. Ay. See, this really bothers me here. Okay, so what you're fundamentally saying is that, which we kind of already knew, is that a SPARQL thing is it's basically entity, it's all about pure relations between things. It's not about, for example, numerical values or anything like that. It's about this has that relation to that. Is that a fair statement?
Yes.
Okay, so, and the point is that as you go collecting, this has that relation to that. You can see which nodes have the appropriate relation structure. Then you can pull out those nodes and do computations on them as you're doing here.
Or the whole path.
Yeah, I mean, I kind of think, okay.
But Stephen, to be fair, this is a very simple query, and in really complicated cases, there are queries which are very hard to formulate in the SQL world, which are possible to formulate in the SPARQL world.
Okay, give me some examples.
Well, I can't off the top of my head. I've seen those, but basically, relational databases are all, they have rigid schema. And there are things which are not really well matched to that schema.
Okay, so like genealogical stuff. Who has
No, actually, genealogical is just fine because you can relate from a table to itself. It's rather that when you have things.
No, but I'm asking things like somebody who has an uncle.
Mm-hmm.
Does that work in the relational world?
Somebody who has an uncle. Yes, why not? You just need to first refer to the father and mother, and then check if any of those have a brother.
I see. Okay. Okay, so then what is an example of something that is hard to represent that way? I mean, these things that, let's say, bibliographic data. So somebody has a co-author who has a citation that has a this, that has a co-author. Is that hard to represent, or is that also easy to represent?
No, that's also easy. I was more thinking about things which are maybe, yeah, I would have to think about it. Something which is not explicitly aligning well with this existing schema of the database.
Okay, so Tony, can you give examples of this?
No, because yeah, I don't know which one is actually harder, but SPARQL queries can be translated to relational queries because the first SPARQL endpoints were.
Okay, so let's look at our own world of stuff here. So what we have in our own world of stuff is we've got, so we've got really two representations here. We've got entity, blup property, goes to potentially some other entity. Could be a value, but it could be some other entity. I mean, that's how that's our current way of doing it. That evaluates to that. Now, what you're saying is that you've got these, RDF triples, entity, property, entity. Is that correct?
Yes.
Okay. So for us right now, this is more like that RDF triple, the presence of that RDF triple is more like something like this, right?
Yes.
Yeah. So, and in general, what we're trying to do, which we're not doing here, is a pattern match play on these things. We could have something which says, find me. Okay, so this is pattern version. So we've got both a pattern version and a function version, I claim. Okay, let's try to understand each of them. So this is the select with a function. Yeah, so this will be a select blah, blah, blah with an entity function, I claim. That is one way.
I think that depends a little bit what you want. Like in this example where you get a value or a single entity, I think that's the right thing. But if you're interested in the past, what connects Albert Einstein to gold, you're more interested maybe in the past than a value.
I understand.
Actually, a very good example. That's definitely something which would be pretty hard to express in easy relational query.
Okay, well, hold on. Let's just understand that. Because the reason it's hard to express, okay, so first point is things it's hard to express relationally. So one thing would be an arbitrary length path. From A to B, right? Because
I think so. Yeah.
What's that?
Yeah, I would think so too. Yeah.
Right. Okay. Now, if you have a finite length path, you can name every waypoint, right? And then you can easily unravel them. If your path is simply going from city to country to population to this to that to the other,
not really, because it might be that even population is one of the things you don't want to name.
Yes. So you may not be interested necessarily what are the intermediates of the path.
Well, I understand that, but you could in principle name them and throw away the names.
Yeah, but in the relational world, that would decide on which way you're kind of walking over the relations. So it's not even clear how you would formulate a query where you don't specify through which tables you're going to go.
Well, I'm sorry, that seems like an implementation issue. I mean, this thing here, right? Yes, you're jumping from table to table here, but surely you handle that in the compilation phase for that query.
No,
Yeah.
what then it means is, you know, it's population, but if you're interested in any property, that will do.
Yeah. So you don't
sorry,
even know
you mean-
which ones you're requesting.
So I see. You're saying if any of those properties, if
Exactly.
is whatever. Okay, so things that's hard to express. So another one is a wild card property, e.g., you know, if there are properties like anyone related in any way to Enron or something, that type of thing, whether it's the accountant, the executive, whatever else. Is that right?
Yep.
Okay, we unfortunately are run out of time here. We need to continue this before we all forget how it works. I think we're making progress here. Next time, we need to make sure Charles and Leonid are both present, because I mean, we've got really two sides to this story. Do we need somebody representing the surf, like Jeremy Michelson?
If we are thinking on this direction, yes, we haven't sorted this yet.
Let's do that.
Okay.
Okay. And I think what we want to do here, I mean, my feeling is that okay, so look, let's box in what we're talking about here. I mean, having something which is merely a binding for SPARQLism seems fine, although I don't know how much, and I think there will be some people who have, who for whatever reason of misspent years or whatever, have large SPARQL endpoint stuff, and they can be very happy. Might be useful to talk to sales or partnerships to find out if they actually know people who've asked about large SPARQL plays, so to speak. I think there have been those over the years.
Yep.
Okay, so we can actually find out who.
I know that Ellen has spoken with a couple of people. I don't know whom.
Okay, fine. Well, let's figure out who they are. Let's try to get a list of who actually cares about essentially the raw native SPARQLism. Fair?
Yep.
Then let's make an assessment of how this can dovetail with our entity function world, the surf world, and the graph world. Okay? And I fully expect that that we'll be able to map some of those things into what Tony has done. Some things will work efficiently, some things will not work efficiently there. But that's, being able to unify the entity function stuff with this graph stuff would be interesting. And the use case, the particular case that I can see doing that for is the surf, which is like just one very complicated entity store. I mean, is it the case? So, Michael, another thing we should come up with is a list of those things, maybe things we're doing internally for which it will be useful to use a graph database, or we are already using a graph database that can be well represented here.
Yep.
Okay, and let's continue that next time. And for those who have been watching this live stream, we'll hope to see you for another episode of the excitements of triple stores, etc. Okay, see you all soon.